Hello and welcome back. In the last video, we introduced a new quantity called heat. Heat gets the symbol Q, and heat is a type of energy that is transferred due to a temperature difference. And recall from the last video that there's three ways that heat can flow. It can either flow through conduction, convection, or radiation. So now what happens when heat either flows into an object or it flows away from an object? Well, the answer is that the temperature and or the phase of the material changes. So what is phase? Well, recall from studies back in high school that there's 4 phases or states of matter. Matter can exist in a gas form, liquid, solid, or plasma. We won't worry too much about plasma, but we will be focusing on the first 3. The phase of a material is dependent on its temperature and its pressure. So when I change the temperature and or the pressure of the material, I can change its phase. Table 14.2 in your OpenStax text provides a list of melting points. Melting points are temperatures at which a material can exist as either a liquid or a solid. And boiling points are temperatures at which a material can exist as either a gas or a liquid for materials at atmospheric pressure. So all those temperatures that correspond to melting points and boiling points for different materials in table 14.2 are all evaluated at atmospheric pressure. So note that if the pressure of a material differs from atmospheric pressure, then the corresponding melting and boiling points for that material at that different pressure will be different. They'll change. So in other words, that table is only good when the materials are at atmospheric pressure. If you change the pressure, then those temperatures also change. So when we add heat to a material that's not at its boiling point or its melting point, then the temperature of that material is going to change. The formula that governs the change in the temperature for the material for a specific amount of heat added or removed from the material is given by Q is equal to mc delta T. Delta T is the change in temperature. Q is the heat that was either added or removed from the material. M is the mass of the material. And C is called the specific heat of the material. And it's, of course, material specific. Every material has a different specific heat associated with it. If heat is added or removed from a material at its melting or boiling point, then the phase changes. And that phase change is governed by the equation Q is equal to mL. Q is the amount of heat that you're either adding or removing from the material. M is the mass of the material. And L is called the latent heat of the material. It's also material specific. In addition, there's going to be a latent heat for the transition between solid and liquid, and then there's going to be a different latent heat for the transition from liquid to gas. The transition from solid to liquid or liquid to solid is going to be called the latent heat of fusion. We'll be going over that more in the next video. The latent heat that governs the transition between liquid and gas is known as the latent heat of vaporization. And again, we'll be going over that in the next video. But this gives you a nice overview of the things that we will be focusing on in the next video. Getting familiar with the phases of matter. And also the two different effects materials can feel depending on what temperature they're at. Either if they're at melting or boiling point, they can experience phase changes when heat is added or removed. And if they're not at a melting or boiling point, then their temperature changes when heat is added or removed. So we'll pick up here next time in the next video. Thank you.